Hi guys, let's go for the part 2 discussion for the chapter coordination compound PYQs. Again, we have one more question from 2019. When a coordination compound, what is a coordination compound given formula? CrCl3 6H2O. That is not the complex, okay? That is a formula of the complex. See, there is no sphere angle, right? This is mixed with, this one mixed with silver nitrate, right? Silver nitrate. 2 moles of AgCl form. Okay, they're saying that 2 moles AgCl form. Okay. What is the structural formula of the coordination compound? Very simple point, my dear. If this complex when treated with a silver nitrate, how you are getting AgCl? This Ag and this Cl get connected. How many AgCl you are getting? 2 chlorine, right? 2 AgCl. 2 AgCl formed mean there should be 2 chlorine outside as counter ion. If 3 AgCl formed mean there should be 3 chlorine outside. That's a meaning. Okay. So 2 mole AgCl formed mean 2 chlorine should be outside. So can you make the formula of the complex? Very careful. Okay. Who is the metal? Chromium. Don't place the all ligand immediately. You have 2 ligand, aqua and chlorine. You may study spectrochemical series, where you can see that aqua is something more stronger than chlorine. Compared to aqua, chlorine, aqua is more stronger ligand. So always strong ligand you have to place it first. So chromium, how many H2O is there? 6 H2O. H2O 6 times. Close the bracket. Sphere closed. Why? Maximum you can place 6 ligand inside. Okay, maximum coordination number allowed is 6. Why you place the 6 H2O? First of all, my dear, H2O is little stronger than halogen. That's why. Clear? So therefore, 3 chlorine should come outside. But this is not our answer. Because if this compound treated with the silver nitrate, you will get 3 moles AgCl because there are 3 chlorine outside. We need only 2 chlorine. So what we can do it? Take 1 H2O out, 1 chlorine inside. Yes? So with the formula will be CrH2O 5 times Cl. 1 H2O out, 1 chlorine inside. You will get Cl2 with H2O. Got it? This compound is having 2 chlorine outside. If you treat it with the silver nitrate, you will get 2 AgCl. Okay? So this is the structural formula of the coordination compound. What is the difference between a complex and a double salt? You know, a coordination complex, let me take for example, CONH3 6 times Cl3. Okay, suppose this is a complex. I'm going to split them. Can you make their ions, my dear? You know this complex, we can write it as, this is 1 ion, this is 1 time, this is 3 time. You know, this 3 come from here, this 1 come from here. Correct. So 1 complex is there, CONH3 6 time, overall charge 3 plus 3 chlorine with a charge -1, 3 Cl -1. So a complex can split like this one. Can you give me one example for the double salt? What do you mean by double salt? It's a combination of 2 salt. We studied in classes like a double salt is called more salt. Right, my dear? More salt. What is more salt? More salt is a double salt. It's having 2 salt. One is ferrous sulfate, one is ammonium sulfate, along with 6 H2O. What is more salt? More salt is a double salt containing 2 components. One is ferrous sulfate, one salt, one ammonium sulfate with 6 H2O as water of crystallization. You know, ferrous sulfate, how it break? Ferrous sulfate break into Fe2 plus and SO4 2 minus. Yes. How ammonium sulfate break down? 2 ammonium, right? So 2 NH4 plus and SO4 2 minus. Even H2O can split it as what? H plus and OH minus. Correct. So can you tell me what is the difference between a complex and a double salt? A complex do not undergo complete dissociation. See, the sphere is existing like that. Metal and ligand, that you can't able to write it as ions. Whereas a double salt undergo complete dissociation in water. See, they all split into their ions. That's a basic difference. So coordination compound do not undergo complete dissociation, whereas our double salt undergo complete dissociation. Please remember one example, more salt. More salt is a mix of ferrous sulfate and ammonium sulfate. Okay, my dear. Okay, I think that our question we discussed, right? Okay, next. What type isomerism is shown by this complex? Can you say fast? Yes, this question already we discussed in our part 1 lecture. See here, chlorine and sulfate can interchange. It's giving you what? Ionization isomerism. What is this ionization isomer? CO, NH3, 5 time, SO4 inside, chlorine outside. Yes, so a weak ligand and counter ion can exchange. This is called what? Ionization isomerism. Arrange the following in increasing order of their crystal field splitting energy. Here all crystal field splitting energy mainly depends on what? Spectrochemical series. Strong ligands make more crystal field splitting, weak ligand make less crystal field splitting. So high crystal field splitting energy mean that is what? That is a strong ligand. High crystal field splitting energy mean that should be a strong ligand. So they are asking you whether you know the spectrochemical series or not. There are cyanide, amine, chlorido. Check the spectrochemical series and can you tell me which is the strongest ligand among this one? Cyanide. Let me mark it this compound as ABC. Which is the strongest ligand, my dear? Cyanide is the strongest ligand, so it make more splitting. After that, amine is the strongest ligand. B, least ligand is which one? C. So we can write in increasing order like this. So if they ask which one make more crystal field splitting and all, use the spectrochemical series. Stronger the ligand, higher the crystal field splitting energy. T2GEG level will be 4. Okay, next one. Write the coordination number and oxidation state of platinum in this complex. What is the complex here? Platinum. Let me calculate the coordination number. Platinum. En is 2 time, right? You know, 1 En provide 2 bonds, so 2 En provide 4 bonds. And 2 chlorine are there, Cl. Total, how many sigma bonds are there? 1, 2, 3, 4, 5, 6. So coordination number is equal to how much? 6. What is the coordination number? It is a total number of sigma bond created by the ligand with the metal atom. What is oxidation state? Platinum, let me take it X. En is neutral, 2 chlorine minus 2, overall 0, X is equal to what? Plus 2. It's 2018, a simple question. Now, write the formula of the following coordination compound. Okay, iron 3 hexacyanidopherrate 2. One of the very good question. This complex you may study in the application of coordination compound under the topic qualitative analysis. Checking the presence of ferric ion. You know, ferric ion in a complex, in a compound is present or not. We can identify by using a complex K4FeCN6. We studied in application part. If a compound contain, not coordination compound, anything. If a compound contains Fe3 plus, you can understand whether it contains Fe3 plus or not by treating with the K4FeCN6. You will get a Prussian blue colored what? What is the Prussian blue color? Fe4 FeCN6 3 time. This complex is the name iron 3 hexacyanidopherrate 2. Hexacyanidopherrate 2. This complex having a Prussian blue color. If you are getting the Prussian blue color, you can confirm the given complex contain what? Ferric ion. So that is the complex iron 3 hexacyanidopherrate Fe4 FeCN6 whole thrice. What type isomerism exhibited by this complex? Again, it is repetition. You know, sulfate and chlorine can interchange and it can show which isomerism? Ionization isomerism. And the next question, write the hybridization and number of unpaired electron in the complex COF63-. I think the same question we discussed in the part 1 lecture. So I'm not wasting your time. I'm not repeating again. Okay. That meaning that, you know, previous year question paper, many repetitions can happen. Okay. Carefully practice at least the last 10-year paper and go for the exam. It will be same time. Okay. I think this question already we discussed in the previous one. So I'm not repeating again. You will get the complex. You can check it. Okay, this complex you will get octahedral shape with an sp3d2 hybridization. Number of unpaired electron we can calculate. Write the IUPAC name and write the formula of the complex. Okay, using IUPAC. Sodium. Okay, what is meant by sodium? Na. Dicyanide. Dicyanide means Cn twice. Orate. What is orate, my dear? Gold. Okay, gold is called orate. When gold come in the anionic part, it's orate. As per now, sodium 1, gold X and 2 cyanide minus 2 overall 0, you will get is equal to plus 1. But we need to get, yes, plus 1 only, no? So we can write like this one. Yes, clear all? Sodium 1, gold X, 2 cyanide minus 2. So you'll get minus 2 is equal to plus 1. Already 1 is the oxidation state, so no need to make any adjustment. Next one. Tetraamine. What is tetraamine? NH3 4 time. Chlorido Cl. And nitrito N. What is nitrito N? NO2. Platinum PT. Okay, once again, let me check. Tetraamine, okay. Chlorido, okay. Nitrito N, okay. Platinum sulfate, outside sulfate. Let us check if the oxidation state correct or not. Platinum X, amine 0, chlorine minus 1, NO2 minus 1, a sulfate minus 2, overall 0, X equal to plus 4. Check it plus 4 or not? Yes. Already correct, so no need to make any adjustment. What type of, 2017, what type of isomerism is shown by the complex? Very simple. If they given two coordination complexes, sphere. If they given two coordination spheres, can you check what is the difference here? Here ligands can be the exchanged. So two coordination sphere, if they given, what is isomerism we studied? Coordination isomerism. Coordination isomerism. What do you mean by coordination isomerism? In two sphere, the ligands or the ions are exchanging. So two coordination spheres, if they given like this one, it is basically what? Coordination isomerism. Next question. Why a solution of the first complex is green while the solution of the other one is colorless? Something is colored means they contain unpaired electron. They make which transition? DD transition. DD transition is the reason for color. If it is colorless, there is no unpaired electron. That is the meaning. So let us show with the help of VBT. Okay. So let me take the first complex is what? NiH2O 6 times 2 plus. Okay. Let us do it fast. Okay. This is a repetition. Nickel is atomic number 28. So what is the ground state, my dear? Argon 4s2 3d8. Here nickel charge is 2 plus, right? So nickel 2 plus means these two lose. What is remaining? 3d8 4s0. And aqua, it's a weak ligand. So 8 electron, how they exist? 8 electron, how they exist, my dear? 1, 2, 3, 4, 5, 6, 7, 8. 4s is free now. After that 4p is free now. Then R4d is free now. Total 6 ligand we have to accommodate, right? So let me take 6 vacant orbital. 1, 2, 3, 4, 5, 6. What is hybridization? sp3d2. Sorry, here hybridization not required, right? Whether it contains unpaired electron or not? Yes. Unpaired electrons make DD transition. It shows color. That's enough. Hybridization not required. Okay, so last part I am just cutting. Hybridization not required. Let me go for the second compound is NiCN4 2 minus. Same central atom nickel is given. Nickel atomic number 28. Therefore, argon with 4s2 3d8. Nickel charge here it is 2 plus. 2 plus means this gone. What is left? 3d8. Cyanide is, my dear, is a strong ligand. If a strong ligand present, how this 8 electron exists? 2, 4, 6, 8. See, there is no unpaired electron, so it cannot make DD transition, therefore it is colorless. So if they ask you one is colored or colorless mean, apply VBT, show that there is an unpaired electron. If there is unpaired electron, they are colored due to DD transition. If there is no unpaired electron, they are colorless. Okay, next one. When a coordination compound, same one question we discussed here, it's 2016. COCl3 6NH3 is mixed with, this is the formula, this is the molecular formula of the complex, okay? With what? Silver nitrate. They are getting 3 moles of which one? AgCl. I told you, my dear, 3 moles AgCl formed mean there should be 3 chlorine outside. Let me make the formula. Cobalt is the metal. First chlorine and amine. Amine and chlorine, when you consider amine is the strong ligand. Always strong ligand plays first. So NH3 6 times. Maximum ligand inside is 6. Okay, maximum coordination and allowed is 6. And this 3 chlorine should be outside. Yes, this is the formula because there are 3 chlorine outside. If 3 chlorine outside, it will give you 3 AgCl. Done. Okay, and write structural formula, this one, and write the IUPAC. What is the IUPAC name of this compound? Hexaamine, cobalt. Oxidation state how much? 3, right? 3, and outside what we have? Chloride. Clear. Hexaamine cobalt 3 chloride. Clear all of you? And another question again repeated. When a coordination compound CrCl36H2O is mixed with AgNO3, 2 moles AgCl are precipitated per mole. What is the complex? I think the same question repeated. Same question. 2 moles AgCl means there should be 2 chlorine outside. So what is the formula? Cr. I told you that chlorine and aqua, when you consider, aqua is little stronger. So aqua, place it first. H2O 6 times, Cl3 outside. But this is not our answer, right? Because there are 3 chlorine outside. If there are 3 chlorine outside, it will give you 3 AgCl. But we need only 2 AgCl. So put 1 H2O out, 1 chlorine inside. You will get Cr H2O 5 times Cl, Cl2, 1 H2O out. What is the name of this complex? Let's calculate. Penta aqua, right? Penta aqua, 1 chlorine, right? So chlorido, chromium, metal is chromium, right? Chromium. And what is the oxidation state of chromium here? Chromium charge X, aqua 0, 1 chlorine minus 1, 2 chlorine minus 2, overall 0, X equal to plus 3. And can you see chlorine is outside, so chloride. Hope you can able to see 1 H2O is outside. What we can call if H2O present outside? Let's call hydrate. We can call monohydrate. Only 1 H2O monohydrate, 2 H2O dihydrate, 5 H2O pentahydrate, like that. Okay, so that is the way you can make these complexes. 2014 one question. What type of isomerism is shown by the complex? Repetition question. H2O 6 times. So I can make 1 H2O out, 1 chlorine inside. So I can write Cr H2O 5 times Cl, Cl2 H2O. What is the problem here? Here you see H2O 6 times as ligand, here H2O 5 times as ligand. This is our hydrate or solvation isomerism. Those who study the theory, they can able to understand easier. This is the solvation or hydrate isomerism. What do you mean by solvation or hydrate isomerism? Same formula, but it is happened due to the difference in number of H2O as ligand. First complex 6 H2O as ligand, second compound 5 H2O only as a ligand. This is called hydrate or solvation isomerism. On the basis of crystal field theory, write the electronic configuration of D4 system when delta O greater than pairing. Delta O greater means there is a strong ligand. Same question we discussed in part 1 lecture. Hope you studied and hope you revised. What do you mean by D4, my dear? D4 means there are 4 electrons, right? D4 means 4 electrons. But delta O greater means there is a strong ligand. Strong ligand means these 4 electrons undergo pairing. So it will exist like a 2-2. Now they split into what? That is what? First 3 down, first 3 orbital down, last 2 orbital up. So T2G contain 4 electron, EG no electron. T2G4, EG0. Write the hybridization and shape of COF63 minus. Have you noticed that? Same compound we discussed again. This is again octahedral shape and sp3d2 hybridization comes. I think we discussed in the previous repeated question. Next question, write the IUPAC name of the following. What is IUPAC name, my dear? Tetraamine, dichlorido, chromium. What is the oxidation state? Can you calculate? Chromium X, amine 0, 2 chlorine minus 2, 1 chlorine minus 1, overall 0, you will get plus 3. And outside what you have? Chloride. Second question, what type isomerism exhibited by the complex? Second question, COEN thrice 3 plus. Okay, what type isomerism? Here all we studied this complex shows optical isomerism because En thrice is there. If a bidentate ligand, what are bidentate ligand? OX En. Shortcut method I'll tell you. Bidentate ligand like OX and EN, if it comes twice or thrice, okay, twice or thrice. If bidentate ligand present twice or thrice, and also their mirror images are non-superimposable, then they will show optical isomerism. So first condition is okay. It's contain En thrice. Let me draw the shape. You know, it is an octahedral complex, right? How can we judge it is an octahedral complex? Because En thrice mean En is a bidentate ligand. So 3 En provides 6 bonds. 6 coordination number mean octahedral. How can we draw the shape? Let me draw one En, these 2 bond, another En, these 2 bond, another En, these 2 bond. And what is the overall charge? 3 plus. Okay. If you take the mirror image of this complex, can you draw the mirror image of this one, my dear? Charge is there, okay? Don't forget to write the charge. Overall charge 3 plus. What will be the mirror image? This En come to left side, right? This En come to this side. And this En go to the right side. And this En come to the left side. And what is the overall charge? 3 plus. Here also overall charge 3 plus. Have you noticed, are they superimposable or not? They are mirror images. Yes or no? Yes, they are mirror images, but not superimposable. If you take this image and fit on this one, it won't match. So they are not mirror images. So therefore, they show which isomerism? Optical isomerism. Optical isomerism. Careful, all of you. And next question, why is NiCl4 2 minus paramagnetic? Why NiCO4 is a diamagnetic species? Yes, we can able to apply by the help of which one? Valence bond theory. My dear, I think you can able to answer it. No need to waste time. NiCl4 2 minus. I will do one question, okay? NiCl4 2 minus. What is NiCl4? Nickel atomic number 28. So configuration is what? Argon with 4s2 3dH. Here nickel charge you calculate, you will get 2 plus. Nickel 2 plus mean these 2 electron gone. What is remaining? 3dH. And Cl is a weak ligand, so electrons do not undergo pairing. So how 8 electron? 1, 2, 3, 4, 5, 6, 7, 8. This is 3d. 4s is free now. You know, after 4s, which all are free? 4p is free, 4d is free. They are asking only magnetic. Okay, then no need this one. You check it all. Here you can able to see there are unpaired electron. If there are unpaired electron, you know they are paramagnetic. Similarly, what is the problem here? You know, carbonyl is a very strong ligand. Carbonyl is a very strong ligand, so all electrons get what? Paired. Then there won't be any unpaired electron. But don't say in word, write with the step 1, step 2, step 3 method. Okay, VB teaches descriptive exam, all of you. Write maximum, don't conclude immediately within 1 or 2 lines. Okay, apply both VBT for both question. Question 2013, okay. 2013 question, for the complex NiCl4 2 minus, find the IUPAC hybridization shape again. I think this is the same question we did here, right? NiCl4 2 minus we did now. What is the name? I will tell you. What is the name of this complex? Tetrachlorido, right? Tetrachlorido. Nickel is in anionic part. Therefore, nickelate, its oxidation state is 2 and it is an ion. Right? Tetrachlorido nickelate to ion. That's IUPAC name. Hybridization, we just we can able to find out how the hybridization. Same method, same question, okay, same combo. Therefore, you know, total 6 ligand we have to accommodate. Sorry, 4 ligand, only 4 ligand, right? 4 ligand mean 1, 2, 3, 4. So what is hybridization? sp3. sp3 means what is the shape? Tetrahedral geometry. And what is the shape? That is tetrahedral geometry. How can we draw it? Ni, Cl, 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 and what is the overall charge? 2 minus. Clear all? So therefore, VBT is a repeated question for every board examination. Okay, next one. 2012 question, my dear. Give the formula of each of the following coordination entity. First one. What is CO3 2 minus? Carbonate ion. Is bonded to. Okay, one CO3 bonded to one Cl. Okay, let me write one Cl. And one NH3. Okay, let me write one NH3 molecule and 2 bidentate ethylene diamine. That means En twice molecule. Right? Here actually not, I think there is a small mistake here that not CO3 2 minus ion, cobalt 3 plus ion. Okay, let me make a small correction in this one, my dear. This is not CO3 2 minus cobalt. We can write it as bonded to 1 chlorine, 1 amine, and 2 bidentate ligand. Let me write a cobalt 3 plus. Okay, there's a small correction I'm doing. Cobalt 3 plus is the one. So cobalt 3 plus ion is bonded to 1 chlorine, 1 amine, and 2 molecules of En. Okay, so cobalt is the metal. They already said 3 plus is the charge we need to get. 3 plus we need to get. Okay, let me check it. Cobalt as per now X. Chlorine minus 1. Amine 0. En is 0. Overall charge as per now 0. So you will get it how much? Plus 1. But how much we need to get it? Plus 3. Plus 3. If you want to get plus 3, what is the overall charge of the complex? It should be 2 plus. Then only here you will write plus 2. Then only this minus 1 and plus 2 become plus 3. Okay. You know, if there is a counter ion number, we can change it. There is no counter ion. So we can place only the charge of the complex. Okay. So that is the formula. Let me give you one more example for this one. Second question. Nickel 2 plus. So here is the metal nickel. What is the charge? 2 plus. Is bound to 2 water molecule. What is 2 water molecule? H2O twice. And 2 oxalate ion. What is oxalate ion? OX twice. Okay. You want to get overall charge 2 plus. Keep in mind. As per now, let me calculate nickel X. H2O 0. Either you can nickel substitute plus 2 like that you can calculate. Okay. OX charge minus 2. 2 oxalate minus 4. Overall 0. You will get X is equal to what? Plus 4. But how much we need to get? Plus 2. So what is the changes? I think we can write it as what? Minus 2 here. If you write minus 2 here, this instead of this 0, what it comes? Minus 2. So minus 4 come to the right side. Minus 2 plus 4 it become plus 2. Clear? So charges we can able to adjust it. So nickel, okay, nickel is bonded to 2 water, so H2O twice. And 2 oxalate ions, so OX twice. And why we put overall minus 2? Then only you will get nickel charge overall 2 plus. Because nickel X, aqua 0, 4 oxalate, 2 oxalate minus 4, overall charge minus 2. Yes, we get plus 2. Clear all? That is a 2012 question. 2011. Explain the following terms. Definition. What are ambidentate ligand? They are certain monodentate ligand have an ability that's actually contain 2 donor atom, but effectively they can use only 1 donor atom at a time. For example, you know, cyanide, its pair is which one? Isocyanide. Or nitrito N, nitrito O. Or thiocyanate, isothiocyanate. What is denticity of a ligand? Simply we can say the number of donor atom. Monodentate means it's having 1 donor atom. Its denticity is 1. So a denticity of the ligand is defined as the number of pair of electron shared with the metal atom or ion. For example, let me take a amine ligand. Amine ligand. You know, amine is a monodentate, right? Why it is so? Because the amine, this lone pair, what is lone pair? 1 pair of electron can donate, they form 1 bond with the metal. Means 1 donor atom. So it is the number of pair of electron. How many pair of electron? 1 pair. That means denticity 1 donor atom. Shared with the metal atom or ion is called denticity. What is crystal field splitting in an octahedral complex? You know, in octahedral complex, how the splitting, we studied like the diagram and all, right? When the d orbital of the metal when present in the average energy state, they split it into 2 sets. The below level is called what? T2G. Upper level is called which one? EG. You know which all orbitals are lying in T2G. Which all? dxy, dyz, dxz orbital. Whereas in this case, dx square minus y square and dz square are the orbital present. And you know the difference between the T2G and EG is called what? Delta O, called CFSC, right? It's called what? CFSC, crystal field splitting energy. So they ask you to draw the crystal field splitting either in octahedral or in tetrahedral geometry. So carefully study the diagram which we discussed in classes. And 2010 question, name the following coordination compound according to the IUPAC name. Okay, first one system. Here 6 amine are right. Okay, we can start hexaamine. You know very well. The amine and aqua present amine first because AM first, right? So hexaamine, then aqua, then chlorido, cobalt, right? Chlorido, cobalt. What is the oxidation state? You calculate, my dear. Cobalt X, amine 0, aqua 0, 1 chlorine minus 1, 2 chlorine minus 2, overall 0, X equal to how much? Plus 3. So we can write 3 and outside what we have? Chloride. Second one. What is the name of this compound? 2 chlorine is there, En twice is there. So dichlorido. Don't forget alphabetical order. Okay, dichlorido. Bis ethane 1,2-diamine. Don't add this B in the alphabetical order. Okay, only the name of the ligand we consider. Chlorido ethane 1,2-diamine. Ce. Okay, C first. Dichlorido bis ethane 1,2-diamine. Chromium. Okay, metal is what? Which one? Chromium. What is the oxidation state you calculate? 2 chlorine, 1 chlorine, total 3 chlorine, you will get 3. So 3 and outside what we have? Chloride. Okay, dichlorido bis ethane 1,2-diamine, chromium 3 chloride ion. Okay, not ion, it's okay, fine. Okay, I think it's clear. So what all importance area you have to focus on our coordination compound chapter is, my dear, again I'm reminding you, study all ligands, their charge and what are the types of ligand. Monodentate, bidentate, polydentate, ambidentate, chelating ligand. Study how to calculate the oxidation state of a metal, coordination number of a metal. Study how to write the IUPAC name of a complex and name to structure, structure to name. Study what is Werner's theory. According to Werner's theory, every central metal atom possesses 2 valency. One is called primary valency and secondary valency. Primary valency is also called ionizable valency. Secondary valency is also called non-ionizable valency. Primary valency give you the oxidation state. Secondary valency give you the coordination number. Valence bond theory must question, my dear. They ask you find the geometry, whether it is inner or outer orbital, whether low spin or high spin complex, whether colored or colorless, para or diamagnetic. Crystal field theory, please study the crystal field splitting in octahedral and tetrahedral, the diagram, and also how to arrange electron in D, 2G and EG. When delta O greater means very strong ligand, delta O less means weak ligand. Study the application of coordination complex, qualitative analysis, quantitative analysis, biological system, medicine, metallurgy, everything we discussed. Even in the most important NCERT question we'll discuss. Then what are metal carbonyl, the synergic bond explanation, careful. How the sigma bond and pi bond is forming. Why coordination complexes are colored DD transition? Because of the presence of unpaired electron. And stability of a complex mainly we explain by the check it by giving a complex if they asking you which is more stable and all. Check chelating ligand is there or not. Chelating ligand means more stable action. And study what is spectrochemical series and the complete arrangement. You should have a clear idea which are strong ligand, weak ligand, like that. And don't forget to study the isomerism, very important area. I hope you clear everything, and those who have any doubts means just pause the video just to see the explanation once again, and make a concentration on the chapters, and wish you all the very best. Do your hard work, do your maximum in the examination. Wish you all the very best.